All right, children, we got a little bit of algebra review here, and we got Miss Zaleski in the house. Woo woo! So you never know, you might hear in the background, saying things and stuff. All right, it looks like we have some awful math equation inputs here, so I'm going to rewrite this in a much better way. It's 3 root 2 or root 5 squared plus 3 root 2 squared equals x squared. Okay, my goodness, that was crazy. So what should we be doing here? Well, I'm sure that many of you are like, hey man, let's just square both sides. We get rid of all those squares. But you got to remember addition in between those two. You can't do that yet. That would be illegal in the world of math. All right, it'd land you in math jail. Scary, scary place. All righty. What we got to do is we got to first square these individual parts. So we're going to distribute those squares because we got two pieces that are multiplied together here, right? That's what's implied as this is multiplication. So 3 squared is 9, and root 5 squared is 5. 9 times 5 is 45. Plus 3 squared is 9 times root 2 squared is 2. 9 times 2 is 18, and that equals x squared. Now I've got to add these two together. Can we do this in our head? I think so. We got 63 equals x squared. Now I can go ahead and square root both sides. And I'm going to break down that root 63. I'm going to bring that up here so I got a little bit of room to work. 63, we're going to break that down. I'm going to do 9 and 7. And I know the square root of those, well, I can do the square root of 9, right, and bring that out, so I get 3. And then I cannot take the square root of 7. Boom. All right. I saw a child do this in class the other day where they left the numbers in the radical, and I think that was pretty groovy, if you will. Pretty groovy. So that way I know I can take the square root of 9, but I cannot take the square root of 7. That's going to stay. All right. Uno más. Once again, we have a lovely little issue with the input of this, the importing of it. There we go. All right, so what should I do here? How about we isolate the squared part by subtracting 9 so we get 16. Square root both sides. X equals plus or minus 4. Mr. Allen just realized he forgot something. What did Mr. Allen do? Oh my goodness, Mr. Allen. Got to have the plus or minus there for that one as well. So if you were like, yo, dog, what's Mr. Allen doing here? He forgot the plus or minus. Indeed, he did. But I'm going to leave it there because everybody makes mistakes. Even Mr. Allen with the Costco executive membership that he has can make some mistakes here and there. All right, time to get into some 3D figures, all right? The last section of this first part of Chapter 9 before we test. Woo! All right, we got a rectangular solid, so they have faces. How many faces do they have? They have 6 faces, right? Some people are 2-faced. This rectangular solid is 6-faced. I mean, imagine how complicated this thing would be to be friends with, you know what I'm saying? All right, so let's name the faces. I'm just going to name one of them, and hopefully you get the idea here. B, D, F, H would be one of the faces, and that would be a rectangle, right? Could be a square, but a rectangle nonetheless. I mean, we could do one more just for fun. How about A, B, H, G? That's another face, and we can go all day with that, well, at least until we name all 6 of them. Cool? So you name the faces with the vertices. There are 4 vertices for the faces. Name the 12 line segment edges. Okay, well, the line segment edge is like A, B with a line segment over it. How about H, F would be another one. Cool. Get the picture? I'm not going to label all 12. Hopefully you are Gucci with this, as they say on the mean streets of Huntley. Name the 4 diagonals. Now, these diagonals of the rectangular solid go through it. So let's say if we start at G, we finna gonna go all the way to D. So G, D would be a diagonal. I could also do that with H, C, A, F, and then E, B, okay? So we could have all those. C, H, what did I say? H, hold up, no. E, B, then A, F, that's what it was. Okay, there we go. So there's our 4 diagonals. That one should be, you gotta go through it because it's 3-dimensional. That's exciting stuff. All right, so a rectangular solid in which all edges are what is a cube? They are congruent, right? It's basically made up of 6 squares. So I can just draw a square here best I can. Boom, boom, boom. Bippity bam. Little dash to show that's behind it. Right? That's exciting stuff. It kind of looks okay. Excellent. There we go. It's a cube. Everything is congruent. All the faces are squares. All the edges are congruent segments. My diagonals through it are going to be congruent. All sorts of congruent, wonderful stuff. All right, we got a rectangular square pyramid, meaning that the base is a square, and we have KLQP. KLQP. Lovely. All right, that is our base of that pyramid. Cool? Then we got a couple other pieces to the puzzle here that we'll go over in a sec. Our vertex of the square pyramid is J. Boom, right up top there. Cool. JM is the height, or you can call it the altitude, right? Height or altitude of the pyramid, and is perpendicular to the base at its center. So JM is our height or our altitude, if you will. All right? And then JN is our slant height. And it is perpendicular to a side of the base. So JN is our slant height. JM is just our regular height or altitude of it. All right? Hopefully that's pretty clear that is the slant height as it is slanted. How creative of them to figure that out. Cool. All right, here we got a box here that is a rectangular solid. So we got this wonderful rectangular solid. It says BC is trace. AB is quattro. And CG is, oh God, dose. That's 12, I believe. Hopefully I'm right. Anyways, 3, 4, and we got 12. I'm going to redraw that 2 for you because it wasn't that there. Oh, that's a nice 2 there. That's real good. All right, so what is BH? I feel like I need a little more information to figure out what BH is. What you're going to find is with these three-dimensional figures we're dealing with, we generally cut things up into right triangles. All right, so I want to figure out what BH is. If I knew what BD was, and I know what HD is because it's going to be the same as CG, so I'm going to start labeling some things with a different color. How about we go with this lovely purple that I've used here and there? So HD is 12. Whoa. Okay. DB, well, that's a 3, 4, 5 triangle because DA is 3. So this is a 3, 4, 5. And if it's 5 with a height of 12, and we know these are going to be right angles, then HB has to be 13. It's a 5, 12, 13 triangle. Mr. Allen didn't even need to use Pythagorean theorem because he knows his triples so well. Maybe one day you'll grow up to be just like Mr. Allen, you know, and know your triples really well. I believe in you, children. Alrighty. Next one, we want AG. Well, AG also one of our diagonals if it were to have drawn, but my pen seems to be having some issues here. Hey, there we go. All right. So AG is also diagonal, so it's going to be the same thing as HB, so it's 13. Oh, lovely. The dimensions of a rectangular solid are 3, 5, and 7. Find the diagonal. Sorry, something's got cut off, but I think we pieced it together pretty nice. Find the diagonal. Okay? Rectangular. Dimensions. Now that looks like a R and then an N. There we go. Okay. Awesome. So 3, 5, and 7. Now where you put those dimensions is kind of up to you. It's I'm going to do this. We're going to go 3, 5, and 7. Okay? If you had the 3 here and the 7 here, the 7 here, that's totally fine. If you had the 3 over here and the 5 here, or the 3, the 5, and the 7, that's totally fine as long as it's your length, width, and height. It'll work out the same in the end. All right, so let's find the diagonal, meaning we're looking to find HB. We want to find that length, okay? That's our goal here. All right. Well, I've got 3 and 5 for my dimensions. So if I form a right triangle, I'm going to pop this 5 over here. That's not a triple, 3 and 5, so I'm going to have to do a little Pythagorean theorem here. 3 squared plus 5 squared is equal to c squared, so that's 9 plus 25 is c squared, so that's 34. So I get square root of 34. So that's this guy, square root of 34. Okay. And I know my height is 7, so again, I can do a little more Pythagorean theorem. I'll do a different color. 7 squared plus root 34 squared equals c squared. And I'll give you a little tip when you guys are working with radicals and the Pythagorean theorem. Don't even worry about simplifying them during the problem. Just wait till the end. Okay? Now, root 34 can't be simplified, but if it could, I would have still left it for now. So I got 49 plus 34, because I'm going to square it anyway, so it's just going to get rid of it. It's easier to deal with. All right? So now I've got 83. Square root both sides. So I'm going to get square root of 83, and I don't believe that can be simplified. All right. Moving right along. This is fantastic. Isn't it, Miss Zaleski?
Fantastic!
All right, last one here, folks. We got the square pyramid has an altitude PR, right? Altitude or your actual height, however you want to word it. The slant height is PS, and oftentimes we will just call it the altitude so it's not confused with the slant height, but it can be referred to as the height, okay? And the perimeter of JKMO is 40. Well, if it's a square base, I'm just going to jot this down now. I'm thinking all these sides are going to be 10, aren't they? Okay? And then PK is 13. So that's this guy right here is 13. All right. Find JK, LOL, PS, and PR. Well, if I've got side lengths of 10, I'm thinking each one of these guys is going to be 5, right? Cool. And I believe what I've got here, I'm gonna take this triangle off real quick because I'm crazy like that. This would be P, this would be S, and I know I have a right angle right here, and then this guy would be K. So I've taken off this triangle. Well, I know this is 5, this is 13, so what's PS? 5, 12, 13 triangle. Woo! Already got one. JK, oh man, I already did that one too. Mr. Allen, I'm just rolling. I don't even know that I'm getting answers, and I'm getting answers. It's crazy. And lastly, we want PR. So for PR, I'm going to take a look at this triangle right here. I'm going to draw that over here for us. So it's PR, the right angle there, and S. Do I have any of these lengths? Well, I've got PS, right, which is 12. I've got RS because it's also half of 10, right? So this is 5. As it goes to the center, so if it goes to the center and all the way across is 10, then that's going to be 5. It's going to be half of it. Now, this is not a 5, 12, 13 triangle here, folks. It is a little bit of a little trap, I feel like, there almost. Not that we're trying to trick you. That would be just rude. But we kind of are. Alrighty, so I'm going to have, we'll call this just x. How about x squared plus 5 squared equals 12 squared. So I've got x squared is equal to, well, what's 144 minus 25? I believe that's going to be 119. I think I like that. Square root that. I don't believe I can simplify 119, so I'm going to leave it there. Ooh, that was lovely. That was absolutely wonderful. I enjoyed that thoroughly. That was such a fun video. I really hope you guys enjoyed it as much as I did. I know Miss Zaleski enjoyed it. Yes?
Enjoyable.
She says it was enjoyable. Excellent. Wonderful. Have a wonderful day. America, freedom, rock and roll.